Hello everyone. Today we'll be dealing numericals on three-phase induction motor. We know the formula synchronous speed ns is equal to 120 f upon p. So this is the synchronous speed of the rotating magnetic field which is produced in the stator. Slip is equal to ns minus n by ns. That is synchronous speed minus the speed of the rotor. This n is nothing but the speed of the rotor. Percent slip is equal to ns minus n into 100. Let's see with the problem. Here we also have a formula of frequency of the rotor current, that is f dash is equal to s into f. S is nothing but the slip, f represents the frequency of the supply. Right. Now a question is here. A three-phase 4-pole 440-50 Hz induction motor runs with a slip of 4%. Find the rotor speed and the frequency of the rotor current. So basically it is an induction motor. It has 4-pole, right, and it has been supplied with 440 volt 50 Hz supply. It has a slip of 4%, which can be written as 0.04. We need to find the rotor speed and the frequency of the rotor current. So we have these formulas, and these are the only formulas we'll be using throughout the whole problem, right? So let's try to calculate the rotor speed, that is n. So we know that ns is equal to 120 f upon p. So 120 into 50 Hz divided by 4. We get the answer as 1500 RPM. Let's check out. So this is the standard data which will be given by in the exam. So 1500 RPM will be the speed of the rotating magnetic field, that is the synchronous speed. So once you have got, you can just calculate slip is equal to ns minus n divided by ns, right? The value of slip has been given as 0.04, right? Ns we have calculated this as 1500 rpm minus n divided by 1500 rpm. So 1500 rpm into 0.04 equal to 1500 minus n. So just try to calculate 1500 into 0.04 gives me an answer 60 equal to 1500 minus n. So in order to get positive n, move the n to the LHS and move the 60 to the RHS. So it is 1500 minus 60, you will get the answer as 1440 RPM. Now this is the speed of the rotor present in the induction motor. Now I want to calculate the f dash, that is the frequency of the rotor current. So which is given by f dash is equal to s into f. So the value of s is 0.04 which has been given. The value of frequency is 50 Hz. So we get 50 into 0.04 as 2. So this is basically a very simple problem, right? Here you just need to remember the formulas for the synchronous speed. How do we calculate ns? How do we calculate the percent slip? And how do we calculate the frequency of the rotor current? So in this formula he might give you the value of slip and he may tell you to calculate ns and n, or he might give the value of n and ns and he might tell you to calculate slip. So anyways, okay, we'll see with the next problem. A 6-pole induction motor is connected to 50 Hz supply. It is running at a speed of 970 RPM. Find the synchronous speed and the slip. Induction motor has 6 poles. It has a frequency of 50 Hz. Now this induction motor is running at a speed of 970 rpm. So this is the speed of the rotor which is there in the induction motor, not the synchronous speed. So find the synchronous speed and the slip. So we need to find the synchronous speed and the slip. So it is very simple. By the formula of Ns is equal to 120 F upon P. 120 into frequency is 50 Hertz divided by poles. So we get 120 into 50 divided by 6 as 1000 RPM. Now we need to calculate the slip. Slip formula is what? Ns minus N divided by Ns, wherein Ns is 1000 synchronous speed minus N, that is the speed of the rotor, is 970 divided by 1000. So bracket 1000 minus 970 divided by 1000. We get the slip as 0.02. Done. So we just need to calculate the synchronous speed and the slip. So we have these two formulas to calculate the synchronous speed and the slip. Let's see with the next problem here. Now the frequency of the EMF in the stator of a 4-pole induction motor is 50 Hertz, and that in the rotor is 1.5 the Hertz. What is the slip and at what speed the motor is running? That is the question. Now we need to find the slip and at what speed the motor is running, that is the value of N of the rotor and slip of the induction motor. Frequency of the rotor current is 1.5. So it can be written as 3/2 Hertz. 2 into 1, 2 plus 1 is 3/2. Right. The value of pole is 4. Frequency is 50 Hertz of the supply. So first we'll try to calculate F dash here. S into F. Why? Because I need to calculate the value of slip here. So I can calculate the value of slip as slip is equal to F dash upon F. So it is 3/2 whole divided by 50. I can write this as 3/2 as 1.5 by 50, where I can get the answer as 1.5 divided by 50, which will be 0.03. So 0.03 is the answer of the step. Now we'll be calculating the Ns, because we need to find the speed of the motor. S is equal to Ns minus N by Ns. So we need to calculate this formula N. So we already have the value of S, that is 0.03, but we need to calculate the value of Ns. So first we need to calculate the value of Ns. Ns is what? 120 F upon P. So 120 F upon P is what? 120 into 50 divided by poles is 4. So how much do we get? 120 into 50, sorry, divided by 4, that is 1500 RPM. So here we wanted to calculate the slip. So by using the formula of F dash is equal to S into F, we got the slip as 0.03. Now we need to calculate the speed of the motor, which is N. So this is a formula where you can find the value of N. So in this we need to calculate the value of Ns. We already know the value of S as 0.03. So in order to calculate Ns, we are calculating this formula. So this is the frequency of the three-phase supply. These are the poles of the induction motor. So now we'll be able to calculate the value of Ns minus N by Ns. That is the value of N. So here So S is equal to ns minus n upon ns, which is written as 0.03 equal to ns is 1500 rpm minus n divided by 1500 rpm. So you just need to cross multiply. So I'll just write this as 1500 minus n equal to 1500 into 0.03. So let's see, 1500 into 0.3 is 450, not 0.3, 1500 into 0.03 it is. It is 45. This is 1500 minus n. So n is what? 1500 minus 45. We get 1445. We get this as 1445 rpm. So this is how we have calculated the value of ns as 1500 rpm, and we had the value of 0.03 by the calculation of f dash is equal to sf. So by substituting the value of s and ns, we have got the value of ns 1445 rpm. Next problem. A 6-pole alternator is running at 1000 rpm, supplies an 8-pole induction motor. Find the actual speed of the motor if the slip is at 2.5%. So here a 6-pole alternator is running at 1000 rpm, supplies an 8-pole induction motor. So this is my alternator, which converts mechanical to electrical energy, right? And here is my induction motor. Motor is what? It will take electrical energy and convert this back to mechanical, right? So alternator is going to generate electricity, and that electricity has been fed to the induction motor, right? So the alternator has 6-pole, and this alternator is running at 1000 rpm. Now induction motor is having 8 poles, but we need to find the actual speed of the rotor which is present in the induction motor, and its slip is 2.5%. So basically the alternator and the induction motor are coupled. The shaft of the alternator and the shaft of the induction motor are coupled to each other. They are coupled. Okay, so let's try to calculate the frequency of the supply. So whatever supply has been generated, that is AC, its frequency will be 50 Hz. So the same frequency of 50 Hz will be supplied to the induction motor. So for the alternator, we have the formula as F is equal to Pn by 120. Right. So P is 6, N is 1000 rpm, this is 120. So by the formula of 6 into 100 divided by 12, we get as 50 Hz. So 50 Hz is the standard frequency which is used in India. So this is the frequency of the alternator now. So the same frequency of supply has been given to the induction motor, that is AC. So both will be having same frequency now. Now we need to calculate the actual speed of the rotor. So by the formula, S is equal to ns minus n by ns. So in this formula, this is slip, this is synchronous speed, this is speed of the rotor. So here we can find the value of n by this formula. So the value of slip has been 2.5. It is 2.5 in the sense it is 0.25. So 2.5 divided by 100. So the value of slip is 2.5%. So this is written as 0.025. As it is in percentage, 2.5 divided by 100 you will get as 0.025 equal to NS. So we need to calculate NS now. So NS can be calculated by this formula now again. 120 F upon P. 120 into 50 Hertz, what we have calculated here, divided by the poles for induction motor are 8. So 120 into 50 divided by 8. That is 750 RPM. Right. So NS is 750 RPM minus N divided by 750. So how do we calculate this part? So 750 into 0.025 equal to 750 minus N. A simple formula and basic addition and subtraction. So if you multiply these two, we get 750 into 0.025, that is 18.75 equal to 750 minus N. So we want positive N. So take N to the LHS and take shift this 18.75 to the right hand side. That is 750 minus 18.75. 750 minus 18.75. So we get the answer as 731.25 RPM. So this is how the problem is been solved. So the only concept is that the alternator is running at 1000 RPM and it is going to supply an energy of electrical energy to the induction motor, where the induction motor has an 8 pole with a slip of 2.5%. We need to calculate the speed of the induction motor, that is N. Thank you.